Okay, and we are back with areas of triangles using half AB sine C. So we are using a little bit of trigonometry to work out the area of a triangle where you're not given a clear base and height. Usually we do base times height and half it, but sometimes that's not always given. We're just given the sides of the triangle. We don't necessarily know what the height of it is. So we are going to look at using this formula to work out the area of a triangle. Now, if you haven't watched these in the same order that I have made it, you won't have known that I have explained how to label the triangle twice already today. But in case you are watching this one first, because we are not using right angle trigonometry anymore, we are using trigonometry on a non-right angle triangle, we can't label the sides in the same way that we are used to. So we can't have an opposite, an adjacent, and a hypotenuse because they are largely related to where the right angle is in the triangle. And this is by definition non-right angle trigonometry. So it doesn't have a right angle, that's the point. So we are labeling it like this. We label the angles A, B, and C using uppercase capital letters. So this is angle A, this is angle B, and this is angle C. And then we use that to label the sides. I mean, you could label the sides first and go backwards to work out the angles, but you have to make sure your angle and your sides go in corresponding pairs, and they are always opposite each other. So if this is angle A, the side A is opposite it, and we use little letters, lowercase letters, to label the sides. So this is angle B, so side B is opposite it. Angle C, side C is opposite it. And that's how you label the sides. The formula we're going to use to calculate the area of a triangle is this, a half AB sine C. So that means if we have two sides and the angle between them, you can work out the area of a triangle. That's important, okay? It does have to be two sides and the angle that goes between it. Obviously, the formula is A and B and C, but that works with whatever letters you've got. We could have side C, side A, and angle B. We could have side C and B and have angle A. You've got two little letters and the other big one. You've got all three letters, but two are small and one are big, basically. Don't know how much sense that makes, but it remains that you need to have two sides and the angle that goes between them to be able to use this formula. If you don't have those, you need to find a way to work it out. Yeah, so say you're given like C and B and angle B, you could maybe use sine rule, a cosine rule, or have a little play around with it and see if you can work out the angle that you need to then use this formula. But we're not going to go that in depth today. So here you have this lovely blue triangle, and you have, I've already labelled it because I've done this video already, and I made a huge mistake. I had to start over. Just giving you a bit of my inner monologue there. So you would be given, I'm going to rub them off and let's just start from scratch. Oh no, that's too much. Here we go. So you'll be given this triangle in your assessment exam, A-level, IGCSE even, and here it is. Here's your triangle. It's not so blue anymore, but it's fine. You have two sides, 4.2 and 6.9, and you have the angle between them. So you can see that there. So you've got this side and this side, they join up and they have an angle that joins them. So we are going to use those. I am going to ignore the labels that are already on this triangle and I'm going to label it myself. So I want to call the angle I've been given angle C, just because it's C in my formula. No other reason. And then I'm going to call this one A and I'm going to call this one B. And now I'm going to put it into my formula. So my formula for the area is a half times A, which is 4.2, times B, which is 6.9, times sin C, which is 75. I'm going to type that directly into my calculator and that is going to give me the area. And that's it. Easy done, you know? Nice and simple. 13.996. To put that to three 3 significant figures, that 9 is going to round up to make it 14.0, and that is 3 sig figs. I've done it again. I've done this in every single video. I've forgotten my units. We're talking area now, so it's centimetres squared. That's 14 centimetres squared. I've put the 0.0 because I'm giving it to 3 significant figures. Obviously, it is just a placeholder. It doesn't add any value to my number whatsoever. But if you're being asked to give your answer to 3 significant figures, you need that 0.0 to show that there are 3 significant figures there. And that's it. That's as basic as it's going to get. Unfortunately, in A-level, it's not going to be that easy. You're probably going to have to use it within a more complex question. For IGCSE, it could be as simple as that. Again, usually there's something else you have to do. It's often within a sector of a circle kind of question. But it's not outside the realm of possibility that you could just get this as a basic question in an IGCSE paper. A-level, absolutely not. They are going to make it way more complicated. But, you know, you have to have a basic understanding to be able to apply it to a more complex question. Something like this is starting to use it in a more interesting way. We're going to have to use the formula backwards to find the angle when you are given 2 sides and the area. So we have triangle ABC has side AB is 5, side BC is 6, and angle ABC is X. Please draw a diagram for this type of question. You know, don't try and just picture it in your head. Draw the diagram. It'll take you 2 seconds. And it'll help more than you give it credit. Given that the area of the triangle is 12 centimetres squared, and that AC is the longest side, which seems a strange thing to say, but it is relevant, find the value of X. Going back to that longest side part, if you have watched the sine rule video first, then you will know a little bit more about what I'm talking about. But if you haven't, when you have an angle and you put it into the function of sine, sometimes it can give you sometimes two different angles can give you the same answer when you put it into the sine function, okay? Remember that sine is a function, just like multiplication, but there are no 2 values that when you times it by 3, you'd get the same answer. Or are there? Maybe a whole number in a fact. No, there are no 2 values. Oh, I'm confusing myself. Let's forget that analogy. But using the sine function, you can have 2 different values of X that give you the same answer when you put it into the function of sine, okay? I'm going to pop a graph in here, which will possibly just make what I'm saying even worse. But if you remember what this sine curve looks like, it's like this. Obviously it carries on, and there's a bit down here and down there, and all of that fun stuff. But these are your angles. So that would be 0, that would be 180. This is the value you get when you put your angle into sine. So say this is sine X, and that would be some number between 0 and 1. Obviously your highest point is 1. And 0 is down here. So that sine X would give you some number that is less than 1, bigger than 0. If you extend that along though, you have 2 angles between 0 and 180 that will give you the same answer. I'm going to call them theta 1 and theta 2. Both of those angles would give you the same number when you put them into the sine function, okay? The way we get around that is once you've found one, you can do 180, take away that answer, and that will give you the other value of sine, okay? We'll put it into practice, and hopefully it'll make a little bit more sense than me talking about graphs, but let's have a look. So draw your diagram first. Please draw the diagram first. So we have side AB, this is 5 centimetres. This is A, this is B. We have side BC, so it's going like this. it's longer because it's 6. This is 6 centimeters. This is C. And then angle ABC, so it's this one, is X. Join it up to make a triangle. And AC would be our longest side. Given that the area is 12, find the value of X. So I'm going to put everything I know into the formula. So I have 12 is my area is equal to a half times 5 times 6 times sin X, sine X, okay? I'm going to move everything else to one side, leaving me with sine X is equal to something. So I'm going to times by 2 to get rid of the half, and divide by 30 because 5 times 6 is 30. And that gives me 24 over 30. I'm leaving it as a fraction because that is my preference. Anyone who knows me knows I prefer fractions to decimals. If you want to write it as a decimal, then go ahead, feel free. Like I say, it is absolutely a personal preference. To get X on its own, I need to use inverse sine. So to get X, I'm going to do sine minus 1 of 24 over 30, which gives me sine minus 1, 24 divided by 30 is 53.13, blah, 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 blah. Now I'm going to call this x1 because that is one value of x. x2 would be 180 minus that 53, blah, blah, blah. And that gives me 126.8, 6, etc., which is 127 to 3 significant figures. Okay, that is an angle, so I'm going to give it a degrees, and that 127 is the value that I'm going to take. Because I was told that AC is the longest side, the angle X has to be the biggest angle. If it was 53, then the lower bound that the other angles could take is 63, okay? Say, just for argument's sake, that is a terrible triangle. Say for argument's sake, this is 53. I'm going to ignore the decimal and just call it 53. The smallest value, no. This is, I started making this video before, and this is where I tripped myself up and had to stop and start again. I'm going to try not to do that again. So we could do 180 take away 53 is 127. If you half that, you get 63.5. Okay, now this is not an isosceles triangle. This is 5 and this is 6. But your two angles, you know, you could have one that is 63.4 and one that is 63.6, you know. This is the smallest value that the next biggest angle could take, okay? I'm still not sure I'm making an awful lot of sense, but basically this is bigger than 53. And no matter how we manipulate it, one of these angles is going to get smaller because it's not an isosceles. One of them is going to get smaller, but one of them is going to get bigger, and it's just going to get even bigger than 53. So we cannot use 53 for our angle because then it can't be the biggest angle in that triangle. We have to use the 127 because that would absolutely be the biggest angle in the triangle. If we take it away from 180, we get 53. And then by the time we've shared that out between two angles, you know, we're going to get 20 and 33 or something like that, you know. But they're going to be smaller than 127 no matter what they are. I hope that makes sense. I do feel like I've lost myself a little bit. I know what I mean and I can't find the words to say it properly in a coherent eloquent way, but yeah, I hope you followed that and I hope it's made a little bit of sense. The basic use of the formula is really straightforward. It's only when you have this kind of two possible values that you could have where you have to, again, use a little bit of common sense. It's not like a skill that I can teach you or a formula that you can learn. It is a bit of reasoning and problem solving that you have to be able to work out in your own mind. Like I say, my mind understands what I mean, but in putting it onto paper or saying it out loud, I just know I'm not making an awful lot of sense. Okay, I hope that's helped. Thanks for listening to my ramblings about angles and triangles, and have a lovely day.